Welcome back. In this lesson, we will go over Elastic Compute Cloud or EC2 instances in depth. EC2 instances are a foundational pillar in AWS cloud computing. They are the reason we can run our workloads on servers in AWS. EC2 instances are basically virtual machines as a service and can configure these VMs to our workload needs without compromising the compute capacity. The host hardware is managed by AWS, so any failures, replacements, or hardware updates that need to take place will all be done by Amazon. The EC2 instance and operating system is handled by us, the AWS customer. So any instance configuration like OS security or any rules will need to be configured to what we need by us. We can configure these instances to run Windows, Linux, or even Mac operating system. Again, all depending on our needs. We will use EBS volumes to store our data and can use autoscaling groups or ASGs to meet the demand and help instance failures. Autoscaling groups are also handled by the customer because only we know how many instances we will need during our peak workloads and how many instances we will need on a minimum basis to keep our application or service running. So we handle our workload peaks and valleys. So why should we use EC2 instances? Well, EC2 offers high availability for our workloads, meaning if we need to have failover instances, we can handle them through autoscaling groups across different availability zones within the same region. We have the ability to launch hundreds of EC2 instances in different regions all over the world if we need to reach different countries and reduce latency to our end users. As mentioned before, we have complete control over the OS and the configuration behind it. We can run anything we want on the operating system, but at the same time, we are completely responsible for securing the instance and the OS. Some of these instance types are flexible, and we can upgrade our application when it demands a higher capacity of computing power. But at the same time, we can also downgrade our instance type if it seems that our workload is not taking advantage of all the computing resources it has to offer. We also use the pay-as-you-go model with EC2, as we only pay for the resources we use. With a regular server, your company owns it. So remember, a traditional server is part of the CapEx model, and in the cloud, we operate on a OpEx model, or a pay-as-you-go model. So what do our applications require? Just like being on-premise, our workloads require CPUs, memory or RAM, storage in AWS. We have EBS, EFS, and instance storage for EC2 instances. We also need NICs or network interface cards and an EIP or an elastic IP. In AWS, this is an internet reachable public IP address. When we choose our instances, we have to keep in mind the application type we will be using on it. We have general purpose, which are meant for general use. We also have more specialized instance type for different types of workloads like accelerated computing, compute, memory, and storage optimized. General rule of thumb is that as our compute power increases, so will our cost. Some ways of mitigating this cost is by using reserved instances, which is when we make a contract with AWS stating that we will be using that specific instance for either 1 to 3 years, and we can save up to 72% on cost. We also need an AMI or an Amazon Machine Image. We can create an AMI according to our needs, or we can get an AMI that is already pre-configured from the AWS Marketplace. AMIs are basically snapshots of operating system configurations. A snapshot is a point-in-time backup of an instance. We make AMIs from snapshots so that we can reuse the same configurations over and over again without having to recreate the same configuration from scratch, saving us time. Speaking about saving time, we can also use user data to save time. We use user data to launch commands on start. This will configure any settings we want in our EC2 OS in an automated way. If you have used VB scripts and placed them into the startup folder in Windows, this is the same concept. User data will install updates, install software, or will download files to a directory, all in an automated way upon initial start. It does all of these tasks with the root permission level. And finally, I want to mention EC2 metadata. EC2 metadata is simply data about our EC2 instances. Important information like public elastic IP, the local IP, and the instance ID. We can use this information to create variables within our user data scripts. This way, we can run the same user data scripts across EC2 instances without having to go back and update the IP address or the instance ID in the user data script. We can find the user metadata by running this curl command inside of our Linux EC2 instance. I hope in this video I helped you further understand why we should be using EC2 instances over traditional servers and how to start automating your workloads. I'll see you in the next video.